Can you see now?
Not yet, sir. It's gray screen. We're just seeing a gray screen. Like it was. Below that, we can see. We can see that there's something below it, but there's a gray screen
No,
over it.
no, I got it. Let me stop and restart.
Not yet. Again, the same thing.
Now?
Now it's working, sir. Yes, perfect.
So, welcome everybody to the class of today. And today we will continue with what we had started yesterday. And we will do the second part of the lecture on the scientific genius of ancient India. We had discussed the Indus Valley civilization yesterday, and then we moved on to the Vedic civilization in terms of its duration. We also discussed the base knowledge systems of ancient India during the Vedic period. Now, today, let us go into some of the most important and landmark contributions that we have been able to extract evidentially. There obviously are many other contributions which are there, but the pure evidence of that is still not established. But whatever we have got now is a reasonable rich version. So let us go and quickly review some of the landmark achievements that have been made at those times. All of us know what is called the Pythagoras theorem, where given a right angle triangle, we know that a squared plus b squared equal to c squared. And there is a more generalized theorem in terms of area of this. While Pythagoras is said to have stated it in 500 BC, the Sulva Sutras, which contains the Baudhyana Sutras, already expresses this. It says that a rope stretched along the length of the diagonal produces an area which the vertical and horizontal sides put together. And there is a detailed Sanskrit slope for it. So we see that how this was there much 300 years, at least 300 years before what it is credited to by Pythagoras. Now, the Sulva Sutras is a very interesting text. I have given a link below. In Cornell University, there is a paper which describes some of the mathematics of the Sulva Sutras. Much of it is lost, but most of these mathematics that came out at that time came out of the second part of what we saw yesterday in the Vedas, which is the Brahmanas, which is where the people actually started looking at the actions that you have to do. So they used to do a lot of rituals. And in order to do these rituals, they had to set up these rituals. And they had to solve very interesting problems. They had to make a circle of the same size as a square. So they had to make a square and a circle whose areas were similar. They had to make two rectangles which had two squares which were of different sizes, same size, different sizes, but their sum would be equivalent to the size of a larger square. So all these types of structures that they had they were able to, they had to work out certain kinds of mathematics. And in that mathematics, they discovered a lot of geometry, they discovered a lot of arithmetic, and there is a detailed version of that in the syllabus. So I will just highlight a few, two or three very interesting things. So one of them is the Baudhayana theorem, which is also known as, when we read it, as the Pythagoras theorem. The second is the square root of 2. Obviously, the square root of 2 could also come from the Baudhayana Sutra, where you have a right angle triangle of size 1 each, and therefore you could have it that way. But there are others where you could actually calculate it as the sum of a certain set of fractions or series. So here is another one where this Sanskrit slope provides the value of square root of 2 in the Baudhayana Sutra 61 by 2, right, correct up to 5 decimal places. So as we see from these two, it clearly indicates that the language that they used for expressing science was in Sanskrit. Now, Sanskrit was also their language for literature. Sanskrit was also their language for legal matters, and therefore, at that point in time, Sanskrit turned out to be the foundational language. Now, the origin of Sanskrit evolved over a period of time, but the final grammatical structure of Sanskrit is credited to Panini in the 4th century BC. In his book, the HiSTAI, he wrote down the rules of the entire Sanskrit grammar in 400 sutras, created a purified and simplified systematic form known as the classical Sanskrit. He arranged the alphabet in a scientific way depending on which part of the mouth is touched by the tongue and how much air is exhaled while pronouncing the alphabet. I think there is some more of this in the Sanskrit part of this course, where Professor Anuradha Chaudhary will discuss with you the details of how pronunciation of Sanskrit is related to everything that is happening in the body as well. And your body mind is related to the whole concept of your speech. On the other hand, the language and the grammar, very recently, there has been a paper which has shown that in terms of information coding theory, this coding of the table of the Sanskrit Paninian grammar is probably the most efficient such encoding ever possible. So they tried using modern algorithms, various possible encodings of the Sanskrit grammar, and they came to the conclusion that this is the most efficient coding possible. So this was a very, very important achievement of that time, and that set the stage for everything that happened till modern age and modern science and technology. It was, as I said, the language of speech which enabled people to really look at their internals. It was part of the yogic phenomena. On the other hand, it formed literature. The third thing that happened was it formed the basis of science and technology. So that is one of the landmark contributions, as you have seen Will Durant express, that the Sanskrit grammar was a foundation of a large number of other languages and texts. So this, other than the Sulva Sutras, in terms of linguistics, mathematics, coding, and various other things, Panini's HiSTAI and the Sanskrit grammar was a landmark scientific achievement. So the Devanagari alphabet, as you can see, was very, very well structured. It had the vowels and the consonants, And in these consonants were all related to the breath, which part of the speech came out, and which way in which people exhaled and inhaled, and how much of the tongue, how much of the palate, everything was extremely detailed in this alphabet. And moreover, this alphabet has got a very, very unique structure in terms of grammarians and linguists. Now we come to another great scientific achievement of the 2nd and 3rd century BC. The Chanda Shastra, which is a very, very interesting text assigned to Pingala. Pingala was a great scholar, mathematician, as well as a Sanskritist. He was also a great philosopher. Now, the Chanda Shastra contains wonderful, wonderful statements. One of the aspects of the Chanda Shastra, which why is it called Chanda Shastra? Because it is related to Chanda, meter, or music. So it is related to meter and music. And there, for example, let me come to one very interesting thing in the Chanda Shastra. In the Chanda Shastra, he defines two kinds of meter. One he calls, sorry, so he defines two kinds of meters. One he calls the light meter or the laghu meter. The second he calls the guru meter or the heavy meter. Now you can consider the laghu meter to be 0 and the guru meter to be 1, or the laghu meter to be 1 and the guru meter to be 2. Whatever you assign, 1 is the second. And then he comes up with a very interesting Sanskrit sloka. He says that for length L, the number of, so if you consider a light or a laghu to be of length 1 and a guru to be of length 2, then any such musical piece of length n, how many musical pieces of length n can be there? He says, if there are 3 musical pieces of length n minus 1, then followed by a laghu meter plus s musical pieces of length n minus 2 followed by a guru meter, which itself is what we know discovered much, much later in the 15th or 16th century, and we know it as the Fibonacci series. But he completely described this in the Matra Mela. Similarly, in the Halayudhaya's commentary, we had described the Meru Prastha, and this Meru Prastha is nothing but the Pascal's triangle. And the Chanda Shastra also indicates the binomial theorem, which is the combination of the meters in which it works. So the Fibonacci theorem, Pascal's number, binomial theorem, and in terms of the equal to short syllables and long syllables, a notion similar to Morse code was determined. The other very interesting thing that came out during this time was one of the most fundamental contributions of the world ever, which is the discovery of zero or shunya. So Pingala used shunya to describe zero, and this was one of the earliest references to zero. So the discovery of zero in about 200 BC appears in a book in the Chanda Shastras of Pingala Acharya, where he says that in the Gayatri Chandas, one pada has 6 letters. When the number is made half, it becomes 3. The pada can be divided into 2. Remove 1 from 3 and make it half to get 1. Remove 1 from it and 1 gets shunya. Today for us, 0 is an obvious concept. But this concept of 0 is so foundational that it formed the basis. Because the Indians first came up with 0, they were the earliest to come up with the positional number system. Zeros, units, tens, hundreds, thousands, etc. Later on, in one of the courses, we will see that this foundational number system, which was the positional number system along with its numeral values, originated from here and then moved on to all the worlds. The Arabs took it up very keenly, and the Arabs developed algebra, the Arabs developed mathematics, and from the Arabic world, it went into the Western world of Europe. And one of the most famous Arabic mathematicians, logicians was Ibn Sina, who in these times is also remembered because he actually was the person who talked about how to handle pandemics by sanitization, by isolation, and by all these things. So there is a very, very unique movie on Ibn Sina where it describes all what he has done. But coming back to what we are saying, that most of these numeral symbols have propagated all over the world. So, as I was saying, the zero and the place value system was one of the most fundamental contributions that was made. And it is not necessary people used it in terms of using only the decimal number system. They used other number systems. But can any of you write on the chat box why you think the decimal number system came up in general? Can anybody suggest why the decimal number system came up? There are other number systems, but yes, the 10 fingers. It helps human beings to count. So for the human being, counting with the fingers was 10. If we had 8 fingers, we really don't know whether we would be comfortable with the decimal number system. One of the deepest evidences of the expression of zero came up in a birch bark that was found in 1881 in modern day Pakistan in the village of Bakshali, which is called the Bakshali manuscript. And in that document, they use the zero symbol. And here is it. Here, this dot here was the explicit mention of the zero symbol. It did not write zero as we did zero, but it made a circle which depicted at that time shunya. Shunya was depicted by a closed circle which had nothing, as if there is a night sky and you cannot see anything. So there is a very clear evidence that the origin of zero and the place value system came from. That formed a basic foundation of all forms and gave a big leap to mathematics. Because today, sitting down where everything seems obvious, it should be very important to realize that this was a watershed in the movement of science and technology of the world. As we move on from the BC to the AD, you will see that Aryabhatta was one of the greatest astronomers and mathematicians of that time. But during that time, he also had others like Brahmagupta and Varamihira, and they used to have huge debates. They were philosophers and polymath, as well as, yogis and other things. So Aryabhatta hypothesized the rotation of the earth around the sun. And he was one of the first people. While he did not reach the Copernican model, but he still had a very foundational model of explaining the lunar and solar eclipses, not as magic, but due to the basis that the earth rotates around the sun and revolves on its own axis. And he also measured various other things in mathematics. He calculated the value of pi, the first value of pi correct to 4 decimal places. He calculated the first trigonometric table. He also solved the first order Diophantine equation ax plus by equal to c, and the method was called the Kuttaka method. He also found out the sum of these series, which are also, attributed to Gauss and others later on. But all of these are now found to have been done by Aryabhatta. And it is not unnatural that Aryabhatta is revered in the mathematical and astronomical sciences, not only in India, now all over the world. And there are various laboratories in the world where Aryabhatta's statue is. So this is how he stated in Sanskrit the calculation of the value of pi. He says add 4 to 100, multiply by 8, and then add 62,000. The result is approximately the circumference of the circle of the diameter of 20,000. Aryabhatta called it an approximate, asanna value. So this is how he calculated it. It was a very interesting calculation, but it was the first correct value of pi, correct to 4 decimal places. The other concept associated with zero is infinity. His contemporary Brahmagupta was the first to attempt a mathematical infinity definition. Today, even we are dumbfounded by division by zero. So he says that which has zero as a divisor. So whatever is divided by zero lives infinity. And this relationship between zero and infinity is another foundational mathematical concept which enabled the progression of science. Both zero and infinity are base foundational concepts to us. Without these two concepts, I do not think modern age would have progressed. That is why 1,000 years ahead of Europeans, Indian savants knew that zero and infinity were mutually inverse notions. This has now been credited to the Indian scientific diaspora of that time. There is a famous equation nx squared plus 1 equal to y squared, which is called the Pell's equation. And this was attributed to John Pell, who lived from 1611 to 1685 by Euler. But what is wrong is that this is already described by Brahmagupta in the 7th century, and he gave solutions to these equations. He gave solutions to various values of these equations. And therefore, today there is a stress that this was developed at least 1,000 years before the time of Fermat and Pell, who actually started talking about this equation and gave values to it. Brahmagupta was also the first who set up the equation for cyclical quadrilateral, and he developed a new method for the second order Diophantine equations, nx squared plus 1 equal to y squared. That is why he got back to this one, nx squared plus 1. So he was the first guy, first person, scientific person to develop this. There was a Jain mathematician called Mahaviracharya. Mahaviracharya was a Jain mathematician, and he developed this fundamental concept of the square root of a negative number. And now we know that the square root of a negative number, which leads to the complex number system, is actually completely a new dimension which was used for several aspects, and today modern control theory to everything else requires us to rampantly use this concept of the square root of minus 1. And then he also found out the formula of NCR, NPR, and several other things. So these Jain mathematicians, around from 600 BC onwards, but this Mahaviracharya was of the same time as Brahmagupta and others, and it was a very fundamental contribution. So you can see zero, you can see value of pi, you can see square roots of negative numbers, you can see Diophantine quadratic second order Diophantine equations, you can see areas and circles and geometry, trigonometry, as well as astronomy, which later came out to be physics. One of the greatest subsequent mathematicians was the great Bhaskaracharya, and even till other times, many of us have studied mathematics, one field of mathematics which we call Bija Ganitam. What is Bija Ganitam? Can you tell me? Can you type? How many of you have studied this word called Bijaganitam? Bijganit? Yes, algebra. So whenever we studied in our Indian languages, we used to call Bijganit algebra. Bij means that unknown variable, Bija, whose value we seek. The seed variable whose value we seek. So therefore, Bhaskaracharya was the foundation, laid the foundations of algebra, arithmetic, permutations, progression, mensuration, puzzles, and he elaborated all this. And Bijganitam is an advanced treatise in advanced algebra. He also did work in astronomy, both in Graha Ganitam, that means the calculation of the stellar elements, and he developed several ready-to-use tables, and he made various commentaries. Bhaskaracharya was probably the greatest mathematician of that time. And in terms of the movement in history, I think after Aryabhatta, Bhaskaracharya turns out to be one of the foundational scientific luminaries. That is why you will see our first satellite was called Aryabhatta, our second satellite was called Bhaskar. All of us think Sanskrit texts and pieces and pamphlets are all about mantras and all about religious concepts. Here is a manuscript leaf showing how to construct a quadrilateral written in Sanskrit. So Sanskrit provided at that time, till we came to scientific symbols and calculus and other languages, we really had Sanskrit describing almost all languages. Till we had separate languages for mathematics, separate languages for chemistry, separate type of ways in which we do biology. Before that, Sanskrit was the fundamental. There is a slightly disputed aspect, but in the scholar Sayana in 1400 AD referred to a sloka in the Rig Veda. He says that the Sanskrit sloka is written below, but the English version is, thus it is remembered, O Surya, you who traverse 2,202 yojanas in half a nimesa. Now, though yojanas and nimesa is the way in which the eyelid flips. One time the eyelid flips is called one nimesa. And yojana has got number of variations. There are various values ascribed to yojanas, but one of the values of yojanas is approximately 13.5 kilometers, and a nimesa is approximately 16 by 75th of a second. And if you put these two, saying that the sun traverses so many yojanas in half a nimesa, you get about this as the speed of light, which is about 6% from whatever is the speed. In fact, the Indian scholars of that time, Aryabhatta, Bhaskara, and they found the size of the universe, the distance, the length of the universe, as can be seen by a naked eye. So through naked eye astronomy, they could reach an approximate value of the length of the universe without all these telescopes and other types of modern techniques that we have. Just through naked eye astronomy and calculations, you can imagine how powerful and how what sort of mathematics they had developed in those times and how foundational it was. So this is a very intriguing slok. It is debatable, but it is worth investigating further how in the Rig Veda, which is attributed to a few thousand BC, how could they have a sloka which talks about the speed of light in science? We all have studied the sine series, the cos series, the tan series, the pi series, and all of these are attributed to Europeans. Newton and Leibniz, we studied the sine series, we call it the Newton-Leibniz series, the sine and cosine. Then we have the Gregory-Leibniz series, which is the tan inverse as well as the pi. But at least 300 years before that, in the southern India, in the Kerala School of Mathematics, we have a huge treatise. Only a few of it has been revealed till now. And Madhava, in his Yukti Dipaka commentary, talks about some of these series. And today, for example, he says multiply the arc by the square of the arc and take the result, repeating that as many number of times. Divide each of the above numerators by the squares of the successive even numbers. Increased by that number and multiplied by the square of the radius. Place the arc and the successive results obtained one below the other and subtract each from one another. Together, give the jiva as collected together. This is the sine series. And this sine series is exactly the sine series later on attributed to Newton and Leibniz. So the sine series, the cos series, the arctan series, the value of pi, all were discovered in India by the Kerala School of Mathematics at least 300 years before Newton and Leibniz or Gregory. And today we need to know that more and more discoveries are happening. But the other interesting thing is that Madhava and the Kerala school very closely came to the concept of calculus. They started describing it in terms of numbers and in terms of growing series till infinity. And based on that, they were very, very close to the discovery of calculus. We have to see from more texts whether they actually came to calculus. But we also have to remember that in the cradle of the other civilization, where we have in the Egyptian civilization as well as in the Jordan River, we have got now some Sumerian tablets. And these Sumerian tablets also indicate that they were aware of infinite series. They did not talk about sine cos, but they were aware of numbers having been achieved out of infinite series. So there has been independent discoveries, and some of the Sumerian tablets have also found it out. But it is now clearly established that the Kerala School of Mathematics established and defined all these series at least before Newton and Leibniz. You know, in India, there are these unique number systems. We all used to study and we all used to remember, even today when people study for joint entrance examinations or any competitive examinations, they remember their formulae and mathematics through codes and through poetry. For example, we remember the Bodmas rule, BODMAS, all of us know. Then, if you forget the Bodmas rule, in Bengali we used to study it like Babar. How would we remember the Mughal Empire? How would we remember the Mughal Empire? I used to remember it in Bengali. I don't know if you'll understand Bangla, but I used to remember the Mughal Empire as follows. Babar, Hoilo, Abar, Jor, Sharilo, Oushade, which increase means my father again had fever, from which he recovered through medication. But Babar, Hoilo, Abar, Jor, Sharilo, Oushade, if you pick up the first letters, Babar means Ba, which is Babar. Hoilo, Hoi means Humayun. Abar means Akbar. Jor means Jahangir. Sharilo means Shah Jahan. Oushadhe means Aurangzeb. So this is how we used to remember. And in the Indian system, they used to map the numbers and the other things to certain elements. So they had various kinds of alphabet word systems for numbers. One of them was the Bhuta Samkhya system. So the Bhuta Samkhya system used to map these numbers to the earth. So they used to say Eka Chandra. So they used to say 1 for Chandra, 2 for Paksha means day and night, 3 for Netra, 4 for Ved, and so on and so forth. 5 for Indriya, 6 for Ripu, 7 for Rishi, 8 for Vasu, 9 for Grahas, and 10 for avatars. Similarly, Aryabhatta had his own system. One of the very interesting systems in southern India was the Katapayadi system. And they would remember these and convert these into various kinds of letters. The Katapayadi system assigned 1 to Ka, Ta, Pa, Ya, 2 to Kha, Tha, Fa, Ra, 3 to Ga, Da, Ba, La, and so on and so forth. And using this, they would encode things so that you remember it. So this is a sloka that they had written. This sloka says Gopi Bhagya Madhuvrata Shringo Dadid Sandhigha Hala Jivita Khatava Dala Hala Rasandhara. Most of us don't know Sanskrit, but the English version meaning of this is, O Lord, anointed with the yogurt of the milkmaids, we worship, O Savior of the fallen, O Master of Shiva, please protect me. But if you apply the Katapayadi Sankhya on this, you will get the value of pi to 31 pieces of decimal. You know, the brain can remember chanda, the brain can remember rhythm. That is why we remember songs, we remember poetry, but we find it very difficult to remember prose. So the brain has its own rhythm, and based on this rhythm, the calculation in the brain works well. So they would convert all these things into songs which had its own meaning, but it was all encoding. So this Katapayadi Sankhya system was a very, very popular system of encoding. And that is why all our texts were remembered through Shruti, were remembered through memory. And it is through memory that we have carried out these texts. And there was this, in order to enable it to have memory, these were intriguing things. So it is worth going back to our Rig Vedas and all and look whether there is an encoding there. So there are different interpretations of our texts. But is there a mathematical encoding? We have still not been able to discover. Computing algorithms, I've also already talked about solutions to Diophantine equations. I've talked about the Kutaka method, the Bhavna method, and the Chakravala. There was the other one, which was the Chakravala method. All of them had these new methods. And I'm sure that when Professor Shomesh Kumar talks about mathematics of ancient India, he will describe this in detail. My job is not to describe all this in details. In these 3 lectures, I'll give you an overview of what we know. So the Chakravala method, Bhaskara II illustrated the Chakravala method, and for 61x squared plus 1 equal to y squared, he found these solutions and it is listed there. And this was done much, much before Pierre Fermat, a French mathematician, challenges this fellow European mathematicians with exactly the same one. Isn't it an absolute coincidence? Because Fermat is also said to have left some intriguing things that this proof is obvious, that proof is obvious, and things like that. So while he was a great mathematician, these coincidences appear to be quite intriguing. Coming to the other sciences, there was a deep study of chemical sciences. Chemical sciences were studied and known as rasayan. And from the extraction of oils to the modern alchemy, where the science of mercury, where they wanted to convert things to gold, medical tinctures, metallic and mineral preparations, metallurgy, and we shall see some great metallurgy work that was done in India, steel, gold, silver, dyeing, tanning, soap making, glass, but Europeans did glass before us, cement, calcination, distillation, sublimation, all these processes. And I'm sure when we go to chemical sciences, expertise in powders and metallic salts. Can anyone tell me what this picture depicts? Can anyone tell me what this picture depicts? Yes, it is Porus handing over Alexander something. So Porus gave Alexander, the legend says Porus gave Alexander 15 kgs of something in a gold case. The case was made of gold, and he gave Alexander 15 kgs of something which Alexander did not have. Can anybody tell me what was that? Not mercury. Steel. Perfect. It was steel. At that time, from southern India onwards, there was this concept of making steel, very fine steel, which then went on to be called Damascus steel because of its export to the Arab world, where this steel was made into the Damascus swords, which were very fine, very hard, very sharp, and very flexible. So that was something Alexander prized. The second picture is about chemistry and how they used to study chemistry. But we lost out on the Europeans because the Europeans discovered something before the Indians, and that helped them advance in chemistry a little faster than us. Can anybody tell me what was that? Not distillation. What is it that they found? What is it that they did? Not gunpowder. They were, yes, Srijan Das, perfect, glass. They were able to find out glass. And once you have glass, you can see the reactions happen. Because we used to make it out of earthen pots or metallic pots and things like that. And we could only get it by lifting the lid or things like that. But they made it out of glass and they moved a little faster. Medical sciences is one area where Indians made deep advances. We know about Sushruta, Atreya, Jivaka, and Charaka all around the 6th century BC. It is around the 6th century BC that foundational contributions in medical science and technology were made. And all of these came out of this subcontinent. These two were physicians of a very famous personality. Can you guess whom they treated? Who was their contemporary in 6th century BC? Who was their contemporary in 6th century? Which was the biggest empire in India in 6th century BC? Not Chandragupta, not Patanjali, no. Yes, Magadha was the largest empire. Magadha, right. And the capital of that time, who was the king during this time? No. Who said it? I missed it. Bimbisar, Bimbisar. It was Bimbisar. So Jivaka and Sushruta were also treated one great personality of that time. Who was he? Buddha. So Charaka is one of the principal contributors of what is the Ayurvedic sciences of ancient. Charaka was a resident of Kapurthala of Punjab, and he is known as the father of Indian medicine. And he was the founder of Ayurveda, but then it came out in many other ways. And this foundation of Ayurveda, as is always in the Indian philosophy, I had talked to you about what is the microcosmos, me, and the universe, the macrocosmos, and about the subtle elements that exist in the body, which includes the Mula Prakriti, how your intelligence is affected, how your ego and I-ness is affected. It is not just about the material aspects of medicine. It is about both the subtle aspects and how the subtle aspects evolve into the material. So there is a detailed theory of Ayurveda, and today more and more Western people are discovering the science of Ayurveda. I'm sure that there will be a detailed discussion of that in this course. And combining Ayurveda and genomics, I think Professor Jyotirmoy Chatterjee will talk about Ayurveda. Sushruta is obviously reputed to be the first surgeon in the world, and the development of surgery and the instruments of surgery, how the dead body was used for various kinds and various other purposes, and how various surgical instruments were developed. All these are documented in Sushruta's works. And Sushruta developed all these things. For example, people say there's an interesting story that they were the first to discover and find out, do plastic surgery. And the reason for this is very interesting. The reason for this is that they were royal physicians, and the king used to give punishments, cut his nose, cut his ears, and all these punishments used to happen. And funnily, at some point in time, the king would realize that this punishment was wrong. And then the king, as usual, would order the surgeon fix his ear back, fix his nose back. From this arose the need for being able to refix human parts and bodies. And it is from a very unique concept of the legal punishment system and the repair of punishment system that the origins of plastic surgery came up. But obviously, that was the earliest form of that. Economics. Kautilya's Arthashastra is probably the first foundational book which describes government, law, civil, legal, ethics, economics, market, trade, everything else, including the whole of governance. There is no book of governance at any point in time which is as comprehensive as the Arthashastra. And this incorporates Indian philosophy, economic and cultural details, agriculture, mineralogy, and Kautilya's Arthashastra, which he developed in order to establish the kingdom of Chandragupta Maurya, is one of the foundational contributions ever. It has formed the basis of governance for centuries together. But it contains many other details, only a few of them which have been found. As I mentioned it, because of its land reform system, it contains measurement systems. And these measurement systems, which is there in that place, is actually an interesting connect between the Indus Valley civilization and the later Vedic and the post-Vedic civilization. It also contains many other very interesting concepts. And I think we need to study each of these books in a much more scientific way than we have done it. Most of us, we keep all of our text, we cover it by a red cloth, and every day we put flowers and water on it. Instead of that, if we had opened it and studied it in more details with a scientific bent of mind, while understanding that original philosophy, I think we still have the option of doing much better. Science and aesthetics were all combined into a single phenomenon. That is why dance and the grammar of dance, the grammar of music, the aesthetics and philosophy, the theory of rasa, the theory of various emotions, somebody talked about emotions, the theory of various emotions, all of this was studied in great details, and I'm sure that some of that will also be done in this course. Aesthetics is the foundation of Indian culture. The culture of the subcontinent, you go anywhere, there is some drawing, some theme, some original. We just had Onam a few days ago. The flower arrangements. All of us look at how beautiful the flower arrangements look like. But have we seen whether there is a mathematical, whether there is a grammatical, whether there is a thematical rhythm in it? This connect between language, thought, mathematics, life, and emotions, all of them threaded together forms the foundation of Indian science and technology. It is not just a material science concept. And that is why it has to be studied in a deeper way. And while we have to be careful of not making outlandish statements, we also have to be open-minded to understand that there may be something deeper in it, and we need to investigate it. Finally, India's probably most foundational concept was the concept of yoga. And this, our institute's motto is Yoga Karmasu Kaushalam, about how you go beyond the mind and where yoga is excellence in action. And these are the three steps: Tapasya, Swadhyaya, and it's called Ishwar Pranidhana. I have converted it to Satya Pranidhana, but it is called Ishwar Pranidhana. These are the three steps of yoga. And we don't have time to discuss all this. I hope somebody who discusses yoga and this. Then there are three techniques: Hatha Yoga, which is perfecting the body; Raja Yoga, which is the breath; and Laya Yoga, which is the consciousness. And each of this is now being studied for its deeper scientific, philosophic, and how it affects the human body and mind. And I'm sure that during the progression of this course, we will get more of it. And the outcome is what was the fundamental outcome of Indian philosophy, was the union of yourself with the universal. This probably was the foundation of all of this practice of all knowledge systems in India. And that is why Sri Aurobindo, who was one of the seers of modern times, has said that the seers of ancient India had in their experiments and efforts at spiritual training and conquest of the body perfected a discovery which in its importance of the future of human knowledge dwarfs the definitions of Newton and Galileo, even the discovery of experimental and inductive method of science. So we are still to go ahead and do much more on this. I will stop here today, and I will hope that this has. So I'll stop here today, and if there are a few questions, I'll be happy to try and address these questions. Tomorrow, the next class, I will discuss more, and we'll have a detailed question answer session. So does anybody have any questions? I think today there was no disturbance in the class, and I think we went on well. I don't know if everybody was able to hear me, but at least I did not face, except for a few screen. I will send the slides today. I will send these slides out today. I'm trying to check whether I can get the video recordings of these lectures and also send it to you. The Pythagoras theorem, it's a very interesting thing. Pythagoras theorem, the first original statement of the Pythagoras theorem and the idea came from the Sulba Sutras. The Greeks gave a detailed statement of the Pythagoras theorem in a longer way, but the Chinese gave the first proof of the Pythagoras theorem. So, we don't own science and technology. We're just trying to find out and figure out whether we had made contributions. Nobody owns science and technology. Yeah, will we be ever credited for it? That is how, that is why it all depends on the generations like you. It is people like us who have studied other things. We are trying to study and bring it to you so that you can continue more evidence-based research. Those who have class may leave.
Sir, can I just make a technical announcement, please, sir? So just one thing is quickly that it would be great if the students put on their names on their identity that is coming up